Hey everyone, welcome to a preview of the InvokeRE Introduction to Malware Binary Triage course. If you are new to malware analysis or are interested in sharpening your craft, visit training.invokere.com. And now for the video. Hey everyone, welcome to the 11th module of the Introduction to Malware Binary Triage course. Today we will be looking at automating malware binary triage. So at the end of the day, there's a lot of manual tasks that we perform throughout this course that automation can perform for us. So when we are performing malware triage, we want to be able to do as much automated as possible in order for us to not do those manual steps simply because they take so long. So our overall goal is to automate as much as possible. And ideally, we want to extract all levels of the pyramid of pain automatically that we discussed in the first module. We also want to extract any configuration information that we can, such as the ransomware configuration that we looked at in the obfuscation module. And finally, if we are able to establish an automation pipeline, we want to store any information that we extract from malware samples for further analysis later, for performing data analysis tasks such as trend analysis with different types of malware. So there are a number of considerations that we should take into account when looking at automating malware analysis tasks. And if you are part of a commercial organization, you need to ask yourselves, is there a budget available for third-party services that can do this for us? Can we upload to cloud services? Many cloud service providers allow private uploads of malware samples to their platforms that will not be shared with third parties. However, there is always the risk that these samples will leak and can leak potential information related to your organization. And if you do invest in an automated pipeline, do you have the in-house talent to process the results of that automation pipeline? So you can do all this work to establish an automation pipeline, but that doesn't necessarily mean you can leverage the results of that. So these are all considerations that you have to ask yourself when you are doing automated malware binary triage and automated malware analysis. So I want to introduce you to a project that you might have heard of if you are in the space. This is called Assemblyline, and it is a project that is maintained by community members and the Canadian Centre for Cybersecurity. I am very proud of this project simply because I am Canadian, and there is a huge initiative behind this project by the Canadian government, and it is great that there are many different community members that are taking advantage of this, so it is something I wanted to highlight throughout this course. So Assemblyline is a malware analysis triage pipeline that will run a given sample against a number of services, and the results are then provided to the user. This includes a YARA engine that will run the sample against YARA rules that are automatically updated from given sources, and a number of those YARA rule sources are provided by default. So out of the box, it already gives you a lot of value. And other services that are already within Assemblyline as services include Kappa, which is the project that we took a look at to extract different traits from malware samples automatically. And there's also things like configuration extraction services that will automatically extract malware configurations from a given sample. So this is really awesome. I've developed services for Assemblyline for different third-party services, and I can only say great things about this project. So this is the architecture of Assemblyline. Assemblyline provides a web user interface for users to interact with, and it also provides an API that can be used to submit samples automatically using code. And once files are received, they are loaded into a submission queue, which are then dispatched for processing by a number of services. And the sample is submitted to services using a service server API, which then either processes the sample within local services or submits the sample to third-party services using APIs for them to be processed. The results from those services are then stored within an Elasticsearch instance, and the resulting files, so for example, if there are extracted files by services, if there are unpacked files, etc., then those are stored within min.io, which is a file store. And if the user is using the web interface, then the results are retrieved from the Elasticsearch instance, and then they are displayed to the user. We're going to look at a demo of this, so you'll get an idea of what it looks like. Before we do that, let's discuss what a sandbox is. So a sandbox performs dynamic analysis of samples automatically, and it does this through a sandboxed virtual machine. So the virtual machine will receive a sample, and then the sandbox technology will monitor the execution of that sample and provide a report to the user. Collected information from the sandbox environment is typically uploaded to a result server that is then processed further. And a sandbox report is then shown to the user to display what activity has occurred within the virtual machine. So this is extremely useful when performing binary triage, since malware can be submitted to a virtual machine, it can be executed, and then the activity of that malware sample can be provided to the user, or you, who is executing the sample, without you having to perform those actions yourself. So this is an example of a user interface for a very good open source sandbox called Cape v2, and this is used to manage file submissions and view sandbox reports from files that were executed. So in this screenshot here, we have a detection that was made for Azeroth, and then we also have a number of different details that were provided here. We have the type of package that was used to execute the sample. So there are different package handlers within the sandbox that are used to execute the sample, such as if they're scripting languages or an executable, etc. We have the type of virtual machine. So in this instance, there is a Windows 7 virtual machine that was used to execute this sample. We have the date that the virtual machine was used to execute the sample. And then we have an extracted malware configuration. So in this instance, the command and control server of patatas.ace.ug was extracted from the Azeroth sample. And this is the architecture of Cape v2, and this includes a cuckoo host that is responsible for guest and analysis management. So they refer to a cuckoo host in this instance, and for those of you who do not know, Cape is essentially a fork of the Cuckoo sandbox, which was also a great open source sandbox technology. Cape is great because it basically took the Cuckoo code, forked it, and rewrote it in Python 3. So that's why this project is currently actively maintained, and it does not appear that Cuckoo is currently actively maintained. So this Cuckoo host is responsible for guest and analysis management, and it is used to start analysis, dump traffic, generate reports that are then presented to the user within a web interface, so the one that we just looked at. When a file is queued for processing, a clean virtual machine is stood up with the sandbox analysis agent running within the virtual machine, and then the file is provided to the virtual machine that was stood up to execute. It is then executed, and the virtual machine is then monitored by the agent within the virtual machine, and the results are provided back to the Cuckoo host. This is all conducted over a virtual network, and Cape v2 also provides the ability for the operator to pick different exit nodes for the network traffic. So for instance, if you had a VPN that you wanted your malware traffic to go over, you could also send the malware traffic to things like iNetSim that we are doing in this course, etc. So it is very flexible and provides a large amount of support for these different capabilities. So let's take a look at Assemblyline. So this is the Assemblyline user interface. So it provides a number of different options for you to use to submit malware samples. And you can see that in the top right-hand corner here, you have things like notifications. So what's really awesome about Assemblyline is it's actively maintained by the Canadian Centre for Cybersecurity. So whenever a change is made to Assemblyline, this is provided in the announcements tab here. And then we also have user account information settings here. You can even set it from dark mode to light mode, different UI settings, etc. We won't get into all these right now just because there is a large amount of different information. But if we scroll on the left-hand side here, we can see previous malware submissions that were submitted to the Assemblyline instance. And we can also see different results if we click on one of these. So for example, if we click on one of these submissions, we can see a whole bunch of different information that was extracted from the malware sample. We're going to go through a specific example here, but we can see that there was a number of YARA rules that hit for this particular piece of malware. We can see that anti-debug techniques are within this piece of malware that were detected by Assemblyline, etc. So there's a bunch of really cool stuff that we can look at within the submission reports. If we want to look at alerts, you can set up alerts for a particular type of logic that occurs within Assemblyline. So for example, if a certain service provides a certain type of information, you can establish an alert for that. You can search the different indexes within the Elasticsearch instance, and you can also look at the dashboard, which provides an overview of the overall health of your Assemblyline instance. So I'm running this on a small machine. It has 12 cores and 64 gigs of RAM. So this shows you different metrics like, okay, this amount of CPU usage is currently in use, and we have the current amount of RAM in use. I don't know why this is 214, but we don't have to worry about that right now. So, and then down here, we have all the different services that are currently running. So this includes that YARA service that I mentioned. Then we have config extractor, which is extracting those malware configurations that I was talking about. And then we have things like overpower, which is used to process PowerShell. We have JSJAWS, which is used to process malicious JavaScript, etc. So there's a whole bunch of different services we could go through here. There could be an entire course on Assemblyline itself that might happen in the future. But for now, these are just the services that are going to be processing the malware sample and then providing results in that UI that I just showed you. So then we have things like administration. So this is simply modifying different things within the Assemblyline instance. So if we go to services, we can enable and disable and download updates for different services, etc. And then of course there's help. So there's a bunch of really good documentation on the APIs, etc. that are available. So if we go back, let's submit a malware sample and see what it looks like. So I'm just going to submit some samples from lab 2 and then we can look at the results. So let's submit lab 2 example 1. And then we can see that these services are currently running against this. And basically we'll just wait until this processing is finished. And then we can see a whole bunch of different interesting results here. So first, the user interface, I'm just gonna make this bigger. It provides a verdict. So it's given the verdict of malicious here. It shows the date and timestamps for when it was submitted. It shows the priority. So say you have a number of different malware samples that are higher priority, you can set that and then they'll be queued differently. You have the selected services here. So we have a whole bunch of different selected services that were processed. And here we can see a malware configuration was extracted. And we can see that the framework that was used to extract the malware configuration was CAPE. So CAPE v2. This is kind of confusing because the CAPE sandbox wasn't used in this instance, but it is using some code from CAPE. This was authored by RemRum. So shout out to RemRum. And we have a description of the REvil configuration parser and the family of REvil. So we performed a whole bunch of different analysis against this particular ransomware sample, but we were automatically able to identify that this sample is indeed REvil and that we were able to extract the malware configuration that we'll look at in 1 second here. So we have a number of techniques that were identified by Yara, similar to that other sample we looked at. And we can see that, okay, there was a output debug string symbol and kernel 32. So I think this is just a simple anti-debug technique. If it is actually, this might be a false positive actually. So if we look at the Yara info, we can see that the REvil Yara rule from Malpedia was hit. And then we can see that there is also attack mappings. So we talked about the attack framework in the first module and a few other modules when we were talking about different TTPs like persistence. But here we can see that there are attack mapping IDs based on the output from these services, which is also really great. Okay, so if we click on this sample files down here, then we can get a bunch more information. So here we have file identification information. So this is actually the different checksum values that we're calculating manually. So we have the SHA-256. Then we even have things like fuzzy hashes such as SSDeep and TLSH, which are kind of outside the scope of this discussion, but just so you know, these exist and they'll hit on various attributes within malware families to provide a checksum that is fuzzy, in that you can have differences between files and then they'll still be picked up with the same SSDeep hash. We see here that the file type is also identified. So this is an executable Windows PE32, the MIME type, the magic, the entropy, which is essentially the randomness within the file. And this is like distributed over this cool color graph. We have the submission frequency. So say like you were seeing the same malware sample being submitted over and over again, you might want to change your submission pipeline in some way, shape, or form. You have who submitted it. So the admin is the only user that I have right now, but say you had a bunch of different users, you can have a bunch of different users on an Assemblyline instance, and then you can give them different permissions. So say you wanted to have a submission pipeline within your organization that your SOC analysts could submit to, but you wanted to be the administrator, you could do something like that. You have a whole bunch of heuristics, again, that we looked at earlier. So that config extraction, etc. And then we have all these generated tags for a given sample. So that was based on the configuration extraction result. And then if we scroll down here, we can actually see the output of the config extraction. So you remember that JSON that we manually deobfuscated and then looked at? So this was done automatically by Assemblyline. And then those JSON values that we looked at are being presented here. So this is super useful because we can actually store this configuration information in that Elasticsearch instance, and then we can use that to monitor different trends within malware, or we can block extracted domains from the pieces of malware, etc. Okay, so that's a general overview of what Assemblyline looks like. It is freely available on GitHub. You can stand it up right now if you want. If you have a Linux machine sitting around, I think they only support Linux currently, but it is really easy to stand up. They do everything with Docker Compose. So it literally downloads everything for you and then installs everything for you. It's really straightforward. So I would definitely suggest checking out that project, and then we'll have a link to it in the end of this presentation. Okay, so let's get back to the presentation. So we can't talk about automating malware triage without talking about free community services and efforts. The first is Malpedia, which, as stated on their website, primary goal of Malpedia is to provide a resource for rapid identification and actionable context when investigating malware. Openness to curated contributions shall ensure an accountable level of quality in order to foster meaningful and reproducible research. It's effectively Wikipedia, but for malware families. It's a really fantastic resource, so if we want to take a look at it. So first and foremost, Malpedia is a free service offered by this German organization, and it is administered by Daniel Plomin and Stefan Enders. So huge shout out to them for this awesome project. If we look at a malware family, for instance, we can look at Azeroth that we were looking at earlier. We can see that there is alternative names for the malware family. So this is super useful when you're doing research. We can see actors that are making use of this malware family. We can see a description of the malware family and then a huge amount of different references that are made for the malware family. So as you can see, Azeroth's been around a long time. We have references going all the way back to 2017. And then you even have YAR rules that can be acquired for that particular malware sample, which I have included within my Assemblyline instance, which is why you saw them earlier. So another amazing project is Malware Bazaar from abuse.ch, and it has the goal of sharing malware samples with the InfoSec community, AV vendors, and threat intelligence providers. So I will again show you this. So if we look at the Malware Bazaar database, then we can see a bunch of different malware samples that were submitted within the past 24 hours. So we have 58 that were submitted. We have a sample corpus of over 700,000 samples. And if we scroll down here, we can see various tags that have been applied to malware samples. We can see reporters. So a whole bunch of different people will upload malware samples and then tag them with their respective family. And then you have signatures that matched on that particular malware family. And then say we want to look at this Agent Tesla sample, then we can see a whole bunch of different things. So we have, again, the checksum information, we have the file name of the malware sample, we have the size, we have the first time it was seen, basically all that stuff that we saw in Assemblyline as well. We have the person that submitted it. It looks like they've also provided a comment as to where it originated from. We have the number of downloads, etc. Then we have a whole bunch of vendor intelligence. So this is super cool in that we can see, okay, this was run within the any.run sandbox. And then we can see a whole bunch of different activity that was performed by the malware. And we can see a whole bunch of different stuff going on in the desktop here. I don't know exactly what's going on. This is basically the process execution hierarchy of the sample that was made. And then this is all the network traffic that was generated during this sample run, which looks like it was a lot. So if we go back here, then we can look at all these different services. So Cape also processed this and it detected it as Agent Tesla. ClamAV detected it. We have Hybrid Analysis, which marked it as malicious. We have Intezer, which is a machine learning service that will attempt to detect malware families, and they also detected it as Agent Tesla. And then we have Hatching, which is also another sandbox, and it provides a whole bunch of different sandbox context here, which is really cool. Then we even have UnpackMe. So UnpackMe are friends of ours, and they provide a whole bunch of different malware triage services. So I was going to mention them on the next slide, and I will. But they've provided a whole bunch of different tags here and mentioned that this is also Agent Tesla. So it's really great for samples that you don't mind being uploaded to a third-party service because they get triaged and submitted to all of these other free third-party services. So it's a really nice community effort, and I highly suggest checking out the Malware Bazaar service. So we briefly talked about commercial sandbox and services, so I wanted to mention a few here. So first, I'm a huge fan of UnpackMe. Again, these are friends of ours, and they provide industry-leading automated unpacking and triage services. And it also provides a YAR search engine that can be used to run YAR rules against an unpacked corpus of samples. So this is unique in that there are a large amount of packed samples, and they might be submitted to all these other sandbox services, but they might not be unpacked, and therefore YAR rules won't hit against them. So the unpack me service will automatically unpack samples, and then it will perform a bunch of different triage tasks against that sample. So it's extremely useful when evaluating the quality of YAR rules, simply because you can run your YAR rule against those samples, and you can also run your YAR rule against a clean corpus of samples. So other offerings include hybrid analysis, hatching, AnyRun, which are sandbox services similar to Kate v2. We looked at AnyRun in the previous example there, and they provide various levels of extended functionality and configuration extraction services that can be leveraged to perform malware triage at scale. So like everything in life, there is no silver bullet for performing automated malware triage. All these services are typically the first step in an analyst's workflow to see if a sample can be triaged using automation. However, there are a number of limitations. So like YAR rules, automation can result in false positives and false negatives. Therefore, it is important to verify automation outputs when possible to confirm whether the results are accurate. Automation can also be evaded using an almost unlimited amount of techniques, and this includes evading virtual environments based on their characteristics, leveraging automation to implement obfuscation techniques on the fly, automated packing of samples, etc. And therefore, it's important to take outputs of automated systems with a grain of salt and perform manual analysis yourself, which you learned in this course when possible. And with that, here's a bunch of different references to the tools that were used throughout this presentation. I highly suggest checking out those commercial services as well, and just submitting different malware samples you find to those services that are not a privacy concern. And with that, this was a brief introduction into automating malware triage and how it can be deployed locally using various open source projects such as Assemblyline and Kate v2. And automation, again, will never be a silver bullet. However, it can provide an avenue for addressing low-hanging fruit and can greatly assist during the triage process as a whole.